Welcome back everybody with thin lenses, again with optics. Today we're going to be doing more mathematical problems when it comes to thin lenses. And similar to the equations we had for mirrors, they also apply to thin lenses. So just a little recap. 1 over the focal length is equal to 1 over the distance of object plus 1 over the distance of image. And magnification is equal to the height of the image divided by height of object, or it's also equal to negative distance of image divided by distance of object. A few things to, just reminders as well. Focal length, always positive for converging lenses, always negative for diverging lenses. Okay? The distance of the object is always positive. Distance of image. Positive if on the opposite side of the object, negative if on the same size as the object. Alright, so let's continue with this. If you need to pause it to write it down, please do that. Okay, so example number 13. An object 20 centimeters in front of a converging lens with a focal length of 10 centimeters. I guess I will draw it, but you don't have to draw it. If you just want to, you can. So I'm going to just draw a converging lens. And then 10 centimeters away, this is the focal point. And then there's an object here. Like draw this object like this. It's actually at the radius of curvature actually. And you can kind of draw where it's supposed to be to give you a little bit of a sense if you want. I would suggest it. It does take more time and you don't have to, but I would suggest it. I'm probably not going to do it for the future ones, but since it's the first one, we'll do this. Okay, so we're going straight, we're going parallel. And then it's going to be going towards the focal. And then we have this towards the focal. And then, oops, sorry. Like this. So it should be something like this, just a arbitrary drawing, okay? Fake drawing. Okay, find the image distance. So we're looking for this distant image. Okay, so anyway, like the formula has, we have 1 over f is equal to 1 over distance of object plus 1 over distance of image. And we could kind of go look at this and you can manipulate it in the way you want. But right now we're looking for the distance of the image. Okay, so maybe I'll just put this to the other side like this. So I'll do 1 over f, and I'll bring this to the other side, minus 1 over distance of image is equal to distance of object in image, but this means this has to be inverse, okay? So that's how we manipulate it to find the distance image. So let's just plug this in, 1 over f, which is 10. Since this is a converging lens, that means that the focal length is positive. Minus 1 over distance of object, which is 20, is equal to distance image, the inverse of that. So let me put that in my calculator. And we get 20 centimeters, right, of lens, or on the opposite side of the lens. Okay. Part B, what is the magnification of the image? So remember, magnification is equal to negative distance of image divided by distance of object. So negative distance of image is 20 centimeters. And then distance of object is 20 centimeters. Oh, okay, so this magnification is just -1, meaning, like we said, it is upside down. Okay, what is the magnification? -1. Is the image upright or virtual, or upright or inverted? It is inverted because of the negative sign that shows us, and also in our drawing. Is the image real or virtual? It is real because it is on the opposite side of the thin lens. Okay? Alright, so moving on. Example number 4. Thin lens is diverging. An object is 30 centimeters in front of a diverging lens with a focal length of 15 centimeters. Find the image distance. Anyway, I kind of drew it for last time, so I don't think I'm going to draw it for this time. One thing that we should know for a diverging lens, the focal length is negative. So just make sure that you know that. Find the image distance. Okay. Again, the formula is 1 over f is equal to 1 over distance of object plus 1 over distance of image. We're looking for distance of image, so let's do that. 1 over f, bring the distance of object to the other side, so minus 1 of distance of object. And then to find the distance of image, we need to put the inverse of this. So let me plug that in. 1 over f is negative 15. Minus 1 over distance of object, which is 30 centimeters. And then let's see what that equals. Okay, 1 over divided by negative 15 minus 1 divided by 30. And 1. So we got negative 10 centimeters. Okay. So this negative 10 tells me that it is on the same side of the object. Okay. What is the magnification of the image? So B magnification is equal to negative distance of image divided by distance of object. So distance of image is negative 10, so that's just 2 negatives make a positive. And then distance of object is 30, so that we see that this is equal to 1/3 or 0.33. Okay. Is the image upright or inverted? Since it's positive, that means it is upright. And like we said, since it's on the same side, that means this is a virtual image. All right, I hope that all made sense. Moving on. A converging lens forms an image 30 centimeters on the opposite side of the object. The object is placed 60 centimeters from the lens. What is the focal length? What is the magnification of the image? Is the image upright or inverted? Is the image real or virtual? Okay, so let's figure a few. Let me maybe draw it out this time. Form the image 30 centimeters on opposite the object, placed 60 centimeters from the lens. Okay, so object is over here. This one is over here. The image is over there. What is the focal length? Okay, so let's do this. 1 over focal length is equal to 1 over distance of object plus 1 over distance of image. And we're looking for the focal length, so we're just finding the inverse of this. So focal length is equal to 1 over distance of object plus 1 over distance of image, and the inverse of that. 1 over distance of object is 60 centimeters plus 1 over 30. That's the distance of image. Inverse of that, let's calculate it. Divide by 60 plus 1 divided by 30. And then inverse, so we get 20 centimeters is the focal length. Great. What is the magnification of the image? B. Magnification is equal to distance, negative distance of image divided by distance of object. So this will be negative 30 divided by 60. So this is going to be negative 0.5, which tells us that this is upside down, like I initially drew it. So that's confirmed. And is the image real or virtual? It's on the other side, so it is a real image. All right, hope that made sense. Moving on. A converging lens with a focal length 12 centimeters forms an image 18 centimeters on the opposite side of a 10 centimeter tall object. I mean, I guess I'll just draw it even if it's not 100%. I don't know what the word is, but anyway. Focal length 12 centimeters. Draw focal. Okay. The converging lens with a focal length 12 centimeters forms an image 18 centimeters on the opposite side of a 10 centimeter tall object. Okay, so I'm going to draw it like this. That's the image of the object. What is the image object distance from the lens? Okay, so let's figure that out. 1 over f is equal to 1 over distance of object plus 1 over distance of image. This time we're looking for object distance. So 1 over f, I'm going to put 1 this on the other side minus distance of image and distance of object. So we have to find the inverse of that to get rid of the inverse. So 1 over f is 12, converging lens, minus 1 over distance of image, which is 18, is equal to, and the inverse of that, sorry. 1 divided by 12 minus parentheses 1 divided by 18 inverse. That's going to be 36 centimeters. So it's going to be 36 centimeters, meaning it's going to be, I don't know, something over here or something like that. What is the height of the image? So magnification equals distance of image, negative, divided by distance of object. So negative distance of image is negative 18 divided by distance of object, which is 36. So it's going to be negative 0.5. So it's going to be half the height, and it's inverted. So what is the height of the image? So if the height on the opposite side of a 10 centimeter tall object, that means that if this is 10 centimeters, this one's going to be half of that, so that's going to be 5 centimeters. Okay? Is the image upright or inverted? Well, it's negative, so it's inverted. Is the image real or virtual? Since it's on the opposite side, it is real. All right, moving on. A 14 centimeter tall object is placed 20 centimeters in front of a diverging lens. The lens forms an image 10 centimeters away from the lens on the same side of the object. What is the focal length? I guess, okay, I'll draw this. The lens forms an image 10 centimeters away on the same side. Okay, so we have, this is the image. And then this is the object. This is 14 centimeters tall. Okay. Part A, 1 over f is equal to 1 over distance of object plus 1 over distance of image. And what do we look for? The focal length. Okay, so to find the focal length, we just have to find the inverse of this. Put it to the negative 1. So 1 over distance of object is going to be 20 centimeters plus 1 over distance of image on the same side, so that's going to be negative 10. Inverse of that, and let's figure this out. 1 over 20 minus 1 over 10. So the focal length is going to be negative 20 centimeters. This negative, yep, tells us that, again, it is a diverging lens. What is the height of the image? Part B. So magnification equals negative distance of image divided by distance of object. Negative distance of image is negative 10 divided by 20. So that becomes a positive 10 divided by 20, which is just 0.5. So it's going to be half the height of 14 centimeters. 14 times 0.5 is 7 centimeters. Is the image upright or inverted? Everybody says it's upright. Or did I say it's upright? Well, anyway, the magnification is positive, so it's upright. Is the image real or virtual? It's on the same size, so it is virtual. Alright, so that's pretty much it. Thanks for watching, guys. Hope you guys learned a lot with optics, and I'll see ya. Bye.